Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 19th, 2025, about 10 days ago. This paper introduces InsertAnywhere, a two-stage system that first tracks a user-placed object through a video's 4D geometry for clean occlusions, and then uses a diffusion model to synthesize the object, plus matching lighting and shading so it looks like it truly belongs. The paper is titled InsertAnywhere, Bridging 4D Scene Geometry and Diffusion Models for Realistic Video Object Insertion. Okay, and the way it combines geometry with generation leads to some surprisingly convincing insertions. Also, the authors shared a GitHub repo for InsertAnywhere, and it is pretty lightweight right now. You will mainly find the project README with the paper details and a teaser video file to preview results. There are no releases or package downloads listed yet, so it feels like an early stage drop. Figure 1 shows what InsertAnywhere is aiming for, namely insertions that stay locked into the scene as the camera and people move. The full film strip layout illustrates temporal consistency, which means the object does not drift or flicker across frames. The left column highlights the user control region and the reference object image that defines what to insert. The middle and right columns show the inserted handbag and shoes staying plausible under motion and partial occlusion, so the edit looks natural. Figure 2 explains why InsertAnywhere can keep an inserted object stable under motion and occlusion, because it starts from explicit scene geometry before it generates pixels. This figure shows the full two-stage pipeline, from 4D aware mask generation into diffusion-based video object insertion. The left side reconstructs the scene and lets the user place a 3D point cloud object, which then becomes a temporally consistent mask sequence. The right side uses a first frame anchor and guided video generation, so the object identity and lighting stay consistent. Table 1 puts numbers behind the visual wins, showing the method produces insertions that look more like the intended object and stay more stable in video. This table shows the full set of metrics, where higher scores mean better consistency or quality. The subject consistency columns use clip-I and deno-I, which are similarity checks against the reference object. The Rs row leads most columns, including multi-view consistency, which matters because the object should still make sense as the camera viewpoint changes, not just in a single frame. Figure 6 makes the case that the rows plus fine-tuning step is what teaches the diffusion model to match real lighting, not just paste an object in. This figure shows side-by-side comparisons without LoRa fine-tuning versus the full method, where LoRa fine-tuning means a lightweight add-on training that nudges the generator toward better shadows. In the top panel, the bag stays grounded when the door state changes because the lighting adapts. In the bottom panel, the towels get a more believable shadow on the machine and wall. Figure 5 shows that each component in the system fixes a specific failure mode, so the final insertions look both stable and physically grounded. The full grid compares a source video against several partial variants, where ablation means turning features off one by one to see what breaks. The left column lists which switches are enabled. The right side makes the point visually, because occlusion handling and first frame anchoring keep the object from popping or drifting. Alright, 2 takeaways stand out. InsertAnywhere gets realism by pairing explicit 4D geometry, which handles motion and occlusion, with diffusion-based generation that learns lighting and shading instead of doing a flat paste. The broader implication is that controllable video editing may need this geometry plus generative combo to feel production ready. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.